Now, another demonstration that we do that illustrates longitudinal or compression sound waves is the SingingRod demonstration. That is done by using a rod. Now, this is an aluminum rod. It's long, it's solid, and it is smooth. Now, you don't have to have an aluminum rod. Just make sure that the rod is solid and smooth. Now, let me illustrate this. First of all, I must prepare my fingers. In order to prepare my fingers, I'm going to use a substance in this little bottle that's called rosin. Rosin is a very sticky substance. It enables you to better grip something with. It is used in many places. The athlete use rosin all the time. If you've noticed near the pitcher's mound, a pitcher will bend down, pick up a little rag called the rosin rag, rub the rag inside of his hand, and therefore his fingers and hand will get sticky. That enables him to better grip the baseball with. So does a string musician. The person that plays the violin operates a bow, and that rosin is on each of the person's fingers, therefore they can better operate that bow. I'm going to use to better grip the rods, and let me show you how it's done. This is called rosining up your fingers, by the way. I'm going to rosin up my fingers, and then I'm going to rub the rosin inside my hand, and the next thing I'm going to do, I'm going to put some of that rosin on the rod. Now, this is how it's done. Watch what happens. Let's see. Now, I'm going to use another rod, which is a shorter rod, and what will happen here, because the rod is shorter, the pitch will be greater because there will be a greater frequency of vibrations taking place. In other words, the metal is going to move back and forth faster than it did with the longer rod. Okay. It's not a very difficult demonstration to do. All you have to do is grab the rod or hold the rod in the middle with your thumb and forefinger. Now, you don't want to hold it too tight because if you do, it would dampen the vibrations as they travel the length of the rod. Then you'll take the thumb and forefinger of the other hand and you'll pinch the rod. You pinch it and then stroke it. Pinch it and stroke it. Pinch it and stroke it. Pinch it and stroke it. Each pinch and stroke action will support or reinforce the previous pinch and stroke action, and the vibrations will travel to the end of the rod, and they will make the rod move up and down, and we'll hear those vibrations as sound waves. They're called longitudinal or compression sound waves simply because when I pinch the rod, I send a disturbance from my fingers inside the metal. That disturbance moves the metal, and they both travel in the same direction. And when that happens, that is known as a longitudinal or compression sound wave. Unlike a transverse wave, if I take this pencil and if I move it up and down, the pencil being the medium, you notice that the pencil is moving in a snake-like motion. It's sort of bending. But what's happening is the pencil is moving up and down, but the wave is traveling at a right angle. Anytime the wave is a right angle to the medium, it is called a transverse wave.